going on, everybody? Down the funk in this bitch. What the fuck's going on? Sorry for the cursing. It's Sunday. Sunday, fun day. You already know what time it is. It's that time of day. We out here. Another beautiful, beautiful, beautiful day in this world. How is everybody doing? You already know it's time for the formalities. Hello, hi, how are you? I hope you had a great week. All that good shit. What's everybody up to today, man? Everybody been chillaxing? Hopefully so. Hopefully so, hopefully so. Let's see what's going on in the chat up in this bitch. Let us see, let us see. Bam, bam. I've basically just been working on some transplanting, doing house stuff, doing fucking dog stuff, you know what I mean? Taking my dog out, fucking cleaning the cat boxes, all that good shit, man. What up, George? What up, Coltagen? What up, Dab? What up, Z-Bud? What's going on with it? What's going on with it? Thank you all for being here. I really appreciate it. Is the audio sounding okay? You already know what time it is. What's everybody smoking on today? Hopefully everybody's smoking on that fire. Right now, I believe... What's up, Buck to Bill? Buck to Bill. I like Buck the Builder. That's good shit. What's going on? Shit, brother. We're about to get started here, but before we do, we're just chopping it up for a second. Drinking some coffee. About to hit a dab or a joint or a bowl, whatever you guys got. Load one up. Let's get it popping. I'm about to load a dab hit right now. Got some new coffee I'm trying out. I really like it. It's pretty good. It's an espresso roast. Been a pretty damn good day, man. Honestly, I'm not gonna lie to you. Been a pretty good weekend too. Was chopping it up and talking to Coltagen a lot, just about a couple different grow mediums and just trying to get some good cycles going, just where it's like no dead time, you know. Everything's efficient and productive. So. Oh shit, Zabud got the cherries going. That's what's up. But yeah, that's what's going on with me. I'm loading this dab up. Not gonna lie to you, I'm smoking on some motherfucking Reclaim, but that's okay. That is okay. I'm not mad about that at all. Poppin' seeds, what's good, brother? How are you? Good to see you, homie. I was just telling Skunky Steve just this past week or just today or not too long ago, like, I promise you guys I'm getting the fucking giveaways out, dude. I didn't realize how expensive this was going to be, dude. And, like, I tried to do it the other way Coltagen told me, and I had at least 3 people tell me, and it's 3 too many, 3 people tell me that they had their shit, like, crushed or it didn't show up at all. So, like, you know, we can't be having that, so... I gotta bite the bullet, and I have to send the packages that cost money. So it cost me about $5.95 to ship ground in the U.S. So just gonna keep doing that, and yeah, that's kind of what's been the delay currently. I thought I could switch it up and do the letter one. Doesn't really work for what I was doing it for. I think I stuffed them too much, and then it just kind of. When you send them in a letter envelope, they go through like little roller systems and shit. So, kind of just fucking blew them out or crushed the seeds completely. And what the fuck is the point in sending the seeds if they're just gonna get crushed, you know? So, that's what's taking so long on the giveaway stuff. So, bear with me, bear with me, bear with me. Kratos, what's good, brother? Enchanted, what's good, brother? We're about to smoke up a dab hit real quick, and we're going to get started. Nah, popping seeds. You're good, brother. You're fine. You're fine, brother. Don't worry about that. We'll get it worked out. We'll get it worked out. I appreciate you popping seed. You're the man, brother. I've definitely just spilt my dabs, and now they're fucking all over my fingers. Got him. Fuck. Bam, 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 bam. Everybody, that's the Dabarooski fucking, sound alarm. It is about that time, dude. Oh, shit. Oh yeah, Bluesman in the house. What up, brother? What up, brother? You're just in time for the fucking Dabarooski hit. You already know Bluesman got the coffee and kush going. Hopefully you're doing the same. Good shit, Coltagen. That sounds fire as fuck, brother. That sounds fire. Damn, I got these dabs all over my fucking fingers, you guys. Not good. Ooh, shit. We're just gonna roll with it. It'll be alright. Enchanted, smoking on some fucking reclaim of Golden Gauge and Block Party. So it's a mix and match. Dabarooski. Oh yeah. Good shit, Zabud. That sounds fucking fire. What about you, Enchanted? What you smoking on? What's everybody smoking and growing on, since we got more people joining the chat and whatnot? Hey, by the way, cheers, everybody. I'm hitting this dab. This is one of my favorite parts of the week, dude. Right before we get into the meat and bones of the presentation, just kicking back for a second, smoking a fat-ass dab or joint, whatever way you're smoking. Just enjoying this nice little time to sit back, toke, and just talk with my people, man. It's one of my favorite times. Thank you guys for being here. Nice, White Widow fucking Enchanted. Oh yeah, it's always fire in the hole. Always, always, always. I was finishing up some stuff for the presentation before I started, and I was like, you know what? I'm going to wait to smoke until right before. So, been waiting, and yeah, it felt good to smoke. Felt real good to smoke. Queen of Soul, that sounds fire, bro. Is that the Brothers Grimm? Buck the Builder? Is that the Brothers Grimm strain? Nice, Enchanted. That sounds fire. Now, my question for you, Enchanted, since we've talked before too, are you gonna end up using that Growing Queen CBD and the Doctor CBD and trying to incorporate that into some of your own stuff so you can have some more CBD, or is it just something you heard about and wanted to grow? Bluesman, you got the double trouble, dog. What the fuck? You got the cart and the flower? That's what I'm talking about. You fucking smacking the pen and then hitting the flower? My man. Buck the Builder, nice, brother, nice. I've heard really good things about Brothers Grimm. I want to get some Cinderella 99. I want to get Ricky's Hash Plant. They're about to come out with Bubbles Blueberry. Didn't they have a classic like G13 or something like that? The Brothers Grimm. There's another one I'm thinking of. I can't think of it. The Cinderella 99, of course. There's quite a few of them I got my eyes on for them. I just haven't got around to getting them yet because obviously money. Pitts Place. What's good, brother? And yeah, Buck, that's dope, bro. I'm really excited about that. Dad Marino, what's good? Nice, Enchanted. That's what's up, brother. Alright, you guys. I'm just about ready to start. I'm gonna fucking heat this dab up to 535, take one more fucking toke, and we're getting started. Today, mainly, we're just gonna be talking about some recap stuff, reiterating, and then we're gonna be adding on talking about the the Hardy-Weinberg equilibrium equation principle. There's different terms you can say, but it's the Hardy-Weinberg uh, theory equilibrium. So, Pitts, what's good, brother? But yeah, gonna smack this dab real quick. Cheers. Ooh, shit. Shit's hitting hard. All right, let's do it. Let's do it, y'all. DTF and Co's Ohio Grow Show, episode number 6. Hosted by your boy, DTF. Big shout out to Dab Marino, Cultigen Seed Co., P&W Cultivar, and most importantly, all of you here right now watching. Big love to all you guys and gals. There's gals too, but big love to all your gromies. You know what I mean? I really, really appreciate it. I say that a lot, and it's because I do appreciate it. So, yeah, one love to you guys. Thank you. Check out their socials in the bio, and let's get started. So, today we are talking about population genetics and the Hardy-Weinberg equation, presented by yours truly. Oh, shit. I was trying so hard not to cough. I don't know if you could tell I was talking weird. I tried so hard, guys. I couldn't do it. Okay. Okay, I'm good now. So, what is this? What's going on with this? Why is it important? Does it have any significance to what we're talking about? DTF, what? Why? What about your beginners breeders project? Well, this all ties together. This all ties together. And we're just gonna keep building and building and building. I'm doing my absolute best to keep taking this little by little, reiterating terminology, reiterating important concepts, and then building from those. I've been doing my best to do that because I feel like for a time there I was moving a bit too fast with too much information and not enough explanation. So I know sometimes not only is it hard to learn, but to learn when you got so much other stuff going on, because let's face it, you guys, we all got lives besides this right here. So that's another reason why I'm so grateful and appreciative of you guys being here. So the reason of me saying that is because I understand that, there's a lot of stuff on a lot of people's minds, and, let alone learning something brand new and taking what you're learning and trying to utilize it inside your brain and be like, okay, well, how do I make it make sense for me? And like implementing that then into your life and your growth. Like it's difficult, especially with everything else that's going on. So that's why I really truly believe everybody can still learn, and there's no age to learning. You just really have to want to learn. So I'm trying to make it entertainment, but then also enjoyable, but then also not sound too much like a idiot or something, So yeah, just thank you guys for coming around, and don't beat yourself up if you don't understand something, because like I said, I'm learning this stuff with you, and we're going along together. So it's not that big a deal if you don't understand something. Just ask a question, shoot me a message on YouTube, or leave me a message on in the comments, or hit me up on Instagram. My Instagram's in my bio on YouTube here. Right now in the chat, ask Cultigen or ask Dab Marino. They're two breeders. Or if P&W ever stops by, ask P&W. 9 times out of 10, if you're looking for a particular subject matter, information about that subject matter, it's probably the best route to just go to people that are experienced in that, have knowledge in that, and have lived that. So those are people that all I just said that have. So they should be able to at least help point you in the right direction. So don't be afraid to learn. Stick with it. Trying to break it down for you guys just as much as I'm trying to break it down for myself. So let's get into it. Sorry for all the rambling. That's what them dabs will do to you, baby. All right, terminology. Once again, we've talked about this stuff before, but now we're gonna start getting into a lot more complex concepts and theories, and it requires the knowledge from the previous presentations we've talked about. Not saying you gotta have everything on rapid fire information like it's fucking a NASA test or something, but just be aware of these terms. They're not going away. They're going to stay here. So that's why we're still reiterating it, because I know sometimes people forget, but then also there's new people. And it's also just to refresh it right before we just dive into talking about a bunch of new stuff when sometimes we don't remember the old stuff. So terminology, genes. Genes are parts of DNA and carry hereditary information passed from the parents to the children. So it's the same concept as if you have blue eyes, your kids have a chance of having blue eyes. Even more likely they're gonna have blue eyes is if you have a wife that has blue eyes too. Or let's think about it in the plant terminology. If you have two plants that are purple and they both are there, it's 100% apparent their phenotype is purple. If you breed those together, you're more than likely gonna get a purple phenotype out of that plant, and that's because of the genes within that plant. So that's just what this is talking about. So going back to what we just talked about with the color. So that color right there, purple. Well, let's think about why is it still cool to see purple tree? And obviously it's more prominent and more prevalent now than it was way back in the day. And I'm not gonna lie to y'all, I'm 25, so like back in the day for me is like when I first started smoking, which wasn't that long ago, to be quite honest with you. So I'm talking about back in the day and from the aspect and perspective of my elders and the people that taught me. And they always said that, you know, it's like finding gold if you found purple back in the day. So let's think about that in the aspect of a dominant allele with the plant. So a dominant allele is a dominant version, quotations, allele, or parentheses, sorry, is a dominant version of a gene, shows a specific trait even if only one parent passed the gene to the child. So this is for saying that, let's say you have let's go back to Mendel's pea plants. He had the two plants. There was tall and there was short. He crossed them together. He realized the tall plants were more prevalent than the short plants. So the tall gene was a dominant allele. An allele is just a different form of a different variation of a gene, of that gene. So it's that's why it's expressing differently. And it just happens that the tall one is the dominant allele, or the one that's most likely to occur. So think about this in the aspect of a human. So when a child inherits dominant brown hair gene form from their dad, the child will have brown hair because it's a dominant trait. Think about that in the aspect of green bud, purple bud. It's probably pretty it's not always the truth too, but like it's pretty easy to say that the dominant phenotype for most tree is green. So that would be the dominant allele, and the recessive allele, or the one that isn't shown as much, would be the purple. So going to recessive allele, recessive gene that shows a specific trait when both the parents pass the gene to the child. So let's think about that in both the same terms like we discussed, humans and plants. So the humans, when a child inherits blue eyes from both their mom and dad, that's why they have blue eyes. So same thing with the purple bud. Even though it's a recessive phenotype or recessive genotype, it's a recessive gene. When the two genes that are recessive combine, it becomes the dominant or determining factor. So now it is going to be purple because there's no dominant allele to interfere and, you know, become dominant. So the recessive equals recessive. In the plant term, it's just, you know, purple bud, green bud. Green bud is dominant, purple is recessive. So that's what this is saying. All right, so going to this from the alleles, you can have heterozygous, you can have homozygous, and these can be dominant or recessive depending on what the allele is. But so heterozygous is two different forms of a gene, one from the mom and one from the dad, that are different. So if your mom had blue eyes and your dad had brown eyes, that's two different genes combining, so it's heterozygous. So think about that in the aspect of, okay, let's take a short plant that's short and purple, let's cross it to a tall sativa plant that's super green. Those are two completely different things. So because it's two different things, it is heterozygous. So that's how I think of it and associate it with that. Heterozygous means two different. Homozygous, on the other hand, is two of the same form of a gene. So once again, going back to the eye example for humans, if your mom and your dad both have blue eyes, you're probably going to have blue eyes, and this is a homozygous recessive trait. Once again, going back to the bud thing, if you have two plants that are homozygous for big bud, they're going to be homozygous dominant, and they're going to be all big bud. It can be the exact opposite. It can be homozygous recessive, though, too. If it's homozygous recessive, it would be the opposite. So it goes both ways. You can have homozygous dominant or homozygous recessive. So, like we said, alleles. Hey, come on, cat. No. Sorry, my cat's freaking tearing the shit. Allele. So alleles, different forms of a gene which produce variations in the genetically inherited trait. So in the example of humans, it would be different alleles produce different hair colors. Think about it like plants. Different alleles produce different plant colors. Okay, so we talked about this last week too. And once again, if you've been tuning in this whole time, you've seen all these definitions and we've spoken about all this stuff. It's important to keep reiterating it. I know it gets boring or repetitive, but it's very important to keep this knowledge fresh. And yeah, so that's what we're doing. So there's monohybrid and dihybrid crosses. So a monohybrid cross is when there's only one trait that is considered. So if it's homozygous for big bud, just like what you see down there, the capital B's, the two B's, the allele type is represented by the letter, by the capital B. So the capital B is the allele or the trait or gene, but the B is the allele for the big bud. The little b is the allele for the little bud. Therefore, that's why there's capital B, little b. So, the homozygous dominant big bud crossed to a homozygous recessive dominant little bud. Well, not dominant. I was redundant there. I don't think I should have put that, but that's a monohybrid cross because there's only one trait being considered. So it's big bud, little bud. So that's what a monohybrid cross is, and we talked about that in the Punnett squares last week. So in the next slide, we're going to see some Punnett squares, but that B, capital BB crossed to little or lowercase bb will be represented in the Punnett square that is shown next. And once again, mono is 1. Mono equals 1 trait. Hybrid, because there's hybridization going on. Dihybrid, di equals 2. 2 traits are considered for a dihybrid cross. So there's 2 alleles. We have the, like we were talking about already, the dominant and the recessive alleles. So the first trait, one trait that's being considered is that it's a big bud or a little bud. The second trait that's being considered is if it's a green bud or a purple bud. So that's why it's a dihybrid cross, because now there's more than one thing being considered. And now more than one trait is trying to be, like let's say for us, for example, if we're going to take, actually, shout out to Enchanted Grow Culture, the main man. He was just saying in the chat earlier that he had some CBD strains going on, and he wants to take those and put that inside of his own genetics. Well, if he's doing that, he might also be. I can't speak for Enchanted. I'm just giving this as an example and just shouting him out. So shout out to Enchanted Grow Culture again for this good example. He said he's growing the CBD strains, and then if he also has these CBD strains, he's like, man, I love these CBD strains, and I fucking love the effect and the effect when I ingest the White Widow strain, that effect for the way it makes me feel. Oh man, I want that with that CBD. So that's now 2 different traits being considered. Or let's just make it another example of he just wants super big buds that are purple, or he wants super tall plants that are very resistant to mold. Like, so that's just what it's saying. It's 2 different things being considered. So that's just what this means. So once again, going back to the 2 traits for the buds, you got the for the cross, the dihybrid cross. We have trait 1 being the big bud, trait 2 being the green or purple bud. G is going to be the capital G is going to be representative of the green allele. The lowercase p is going to be representative of the purple allele. So if you have capital G, lowercase p, it's a heterozygous dominant green bud. So when you have that combination, it's going to be mainly green. If you have a homozygous, or the same, dominant, the homozygous dominant green bud, that is just saying that there is 2 alleles of the green allele combining, so that therefore is homozygous, and we know that the green allele is dominant, so that's why it's dominant. 2 lowercase p's would be a homozygous recessive purple bud, and that just means that you're going to see purple within the offspring of that, because even though it is a recessive trait, it's consistently being passed on because there is no other trait being considered. It's only the purple trait. So, for example, once again we're going to see a Punnett square of this too. For example, it would be the capital B, lowercase b, which we know is the heterozygous dominant big bud, with the dominant or the homozygous dominant big bud crossed to the heterozygous dominant green bud crossed to the homozygous dominant green bud. So we're going to see 2 different Punnett squares representing both of these, and then we're going to keep moving on from there. But yeah, this is all stuff that we have talked about before, but it is imperative to what we're doing, and this is the Punnett squares is something relatively simple that if you have data or research or notes from previous grows of, oh, okay, I've worked with this cultivar, let's just say for example you've been growing 10 years, and 10 of those years, and out of the 10 years that you've been growing, 5 of those years you've been using the same cultivars, and you've been taking extensive notes about everything, what the plant likes to uptake, what it doesn't like to uptake, what type of weather environment. You get what I'm saying. So you're taking notes of everything. So if you have all these notes and you're repetitively growing the same cultivars, you can start to make these conclusions like Mendel himself did, and use Punnett squares as a determining factor, or like as a prediction for what you're trying to do. So if you don't want purple buds, you're like, man, fuck that purple bud shit, I want them green buds. If that's what you want, and you know that, let's say, and I don't know this for a fact, I'm just pulling this out my ass, but let's just say green crack, just because the green's in the name. Let's just say green crack, right? Let's just say it's predominantly green, right? Like, yeah, man, I love this. I know it's green. I want that. I want it. I have to have it. Okay, well then, you take that and your notes from all of that, and you start to make like predictions with another cultivar that you've been working with for a long time. You have notes with. You're like, okay, well, this one, I know the green crack is green, and this other one I got, let's just say it's purple Urkel. Let's just say purple Urkel. It's like, I got this purple Urkel, and I don't like the purple, but I like the way it makes me feel. Well, then now, and you have all the notes for it and stuff, then now you can start to make like predictions about, and then, well, actually, then what I would do then from there is like, okay, well, if you don't want purple bud, but you still want the effect of that, then you're going to have to go through and pop a bunch of purple Urkels, select only the green phenotypes of it, breed only with those, keep breeding with those, keep taking those to the next generation, the next generation, taking out all the bad qualities you don't want, selecting more green, and then you would take the one that you're like, okay, this is the prime specimen, exact example I want to breed with for my other one, and then basically you would just take letters like this, and then you would make definitions for them, just like I did here for capital B being big bud, and then you start to make your predictions in the Punnett squares, just like so. So like, oh yeah, shout out to Reginald Crundell Punnett. He was the inventor of the Punnett square. Born in 1875, died in 1967. Went to Cambridge. He developed them. He helped introduce statistics via G.H. Hardy, which he's one of the people of the Hardy-Weinberg equation. He asked Hardy, why aren't brown eyes the only allele and the only color if it's the dominant trait? So this led to the Hardy-Weinberg law, along with population genetics and whatnot. But yeah, shout out to Reginald. So the example of the Punnett squares, like we were talking about, and like I already had labeled, if you take these and you cross them with a monohybrid cross, you're going to get one that is completely recessive, so that's represented by the lowercase b at the top one, or the lowercase p on the bottom one on the right hand side of the picture. So you're going to have one recessive trait that is prevalent out of the 4, so that's 25% then. And then the other 75% are also all dominant, but you can see there's different allele combinations. So that's why I was explaining the heterozygous and the homozygous, because you can see represented there is one that is actually homozygous while the other 2 are heterozygous. And the only reason that this is important is because it is these alleles, when they are combining with the other set of alleles from another gene pool, that are combining and then determining what trait is being expressed. So the combination of the 2 alleles and what is expressed is determined by what that allele typically expresses. So that's why if you get 2 recessive traits, even though it's not typically dominant, if you have both of those together consistently over time and breeding over time over many generations, it's going to be within that gene pool, within those genetics, even though that it is mainly a recessive trait, typically predominantly you're only going to see the purple. So that was my explanation why I was saying, or that's my explanation for why I was saying you would take the purple Urkel if you're trying to not have purple but have the effects of it. You'd have to grow a bunch of purple Urkel and only use the green phenotypes to grow with, and then keep breeding with those, keep breeding with them until you find a prime specimen or prime example that you would like, or a prime cut, keeper cut that you would like to breed with. And then you'd have to do the same thing with your other strain for the CBD. Find exactly the CBD, if you're testing for that, find the exact percentages or whatever you want for it in it, and then you would take your keeper cut from that, and then you would take them and cross them together, and then now you're going to have offspring from there. But the Punnett squares is supposed to help visually represent and theorize what you could see if you know what the alleles and the traits are. So that's just kind of why we're reiterating it and talking about it again. And once again, monohybrid is considering one trait. Dihybrid is considering two traits. So, like we talked about, we have the big bud, little bud trait crossed to the green bud, purple bud trait. So it's dihybrid because there's two separate traits being considered. And as you can see, because there's two different traits being considered, there's more possibilities or variations of combinations and outcomes. So that's why there's more Punnett squares. But it's the same concept. As long as you see two of the same, capital B, if that's what it says, that's homozygous. Or if it's lowercase b, that's still homozygous. But remember, those two uppercase and lowercases represent two different alleles. The uppercase B is representing the big bud allele. The lowercase b is representing the little bud allele. So when you have two capital B's, that means it's two big buds. It's dominant for big bud. It's homozygous. When you have two lowercase p's, even though that is a recessive purple trait, that is now going to be the predominantly seen pheno is purple, because there's those two alleles consistently combining together. There's no other chance for the green to come in. So let's look at the very bottom right and the far right corner square where it says lowercase p, and then lowercase b. So everybody find that on the Punnett square real quick. I'm going to take a drink of coffee. I feel like I've been rambling on. Shout out to Led Zeppelin. Please don't strike me on YouTube or whatever. This is my interpretation, entertainment. So this lowercase p, the two of them, and the two lowercase b's, think to yourself, what are these representing from what we've been talking about? I'll give you a second. I give you a second to think about that while I drink another sip of coffee, and I'm probably actually about to warm up this dab again. So if you guys want to just think about what does, well, first question is, if it's two of the same alleles, what do you call that? If it's two of the same. So that's the first question. The second question is, what does lowercase p represent? Third question is, what does lowercase b represent? So answer those to yourself. You don't have to answer them in the chat or nothing. Just kind of answer to yourself. I'm gonna load this fucking dab up again. Hit it. You guys just think about that for a second, and then I'll tell you. I'm just about ready if you guys are. Sorry, I'm being very careful trying to not get these damn dabs on me again, because that shit was messy. Okay. So. Alright, I think I got it. So what do you guys think? You got it figured out? You got it solved? I really think you guys did. I trust you guys. We're gonna see. We're about to find out. We're about to find out. Cheers, everybody. Fat dab rips. I'm not gonna lie. Sometimes I think 60 seconds is too long to be smacking a dab for, because it runs for 60 seconds. This fucking e-rig, and if you're not careful, man, you can fucking damn near throw up. Funny story. I fucking took this over to my cousin's spot one time, and I was like, "Hey, bro, be careful. Don't smack this bitch too hard." And he pulled the classic. Smacking that bitch so fucking hard, this dude threw up. He fucking threw up, dude, and it was the funniest shit ever. Shout out to you, cuz. It's like a fine wine. You gotta sip on it. You can't chug it, or not a fine wine. It's like a fucking. You don't chug liquor normally. So you can't just. Yeah, you just gotta be patient. You gotta be chill with it. It's just it's not one of those things where it's gonna get clogged up. It's gonna hit. Well, I actually let me rephrase that, because it does clog up if you don't clean it. But as long as you clean it out, that bitch don't clog up. So it's always like a smooth, good hit. So a little inhale goes a long way. So that's another reason why I love this damn dab rig. Back to it. So, ooh, damn, I had to take a deep breath. That shit got me. Alright, the coffee got me recentered. We're good. So, if you answered that the 2 lowercase p is homozygous, if you answered that the 2 lowercase p represents the recessive purple bud, and if you said the 2 lowercase b's equals and represents the little bud, you would be correct. That is exactly what that means. So, that is what this is. It's a prediction for your crosses for the different traits that are considered. Once again, this isn't something you can just take brand new stuff you've never grown ever before and then just start like being like, oh yeah, it's gonna do this and this. Well, I mean, if you've never bred with it, how do you know what it's gonna do? If you've never grown it, how do you know how it's gonna grow? Like, you gotta have notes. You gotta have notes. So, and hey, shout out to Coltigen, because he really ingrained that inside my brain and stuff, and just talking about having a plan about what you're doing and where you're going, why you're doing it. So yeah, that's just another thing to take into consideration too. So yeah, that's what that is. If you got that, good job. If you didn't, that's okay too. No big deal. Moving forward. All right, so here we go. This is the new stuff. Population genetics and the Harney. I said Harney because I saw that I misspelled Weinberg. My bad. Hardy-Weinberg equation. So, first off, what is population genetics? Population genetics, per reference, is the field of biology that studies the genetic composition of biological populations, which just means any type of population. So if you're thinking, let's just talk about cannabis because that's what we're talking about. So just let's reread that. The field of biology that studies the genetic composition of cannabis populations. Biological means living. So anything that is living, you can apply population genetics to. So we'll just say it's where our purposes is cannabis, so we'll just say cannabis. And the changes in the genetic composition that result from the operation of various factors, including natural selection. So let's read that one more time. Population genetics is the field of biology that studies the genetic composition of living populations, for our purposes, cannabis populations, and the changes in the genetic composition of those populations that result from various factors, including natural selection. Okay, so what is this? With the Hardy-Weinberg. So it was independently discovered by two different people in the same year. So here we got. So I'm just going to read to you one of the references here. And this comes from the reference below. So the Hardy-Weinberg principle, discovered independently by G.H. Hardy and W. Weinberg in 1908, is one of the simplest and most important principles in population genetics. To illustrate the principle, consider a large population of reproducing organisms. So that's just talking about like we're talking about cannabis. So just consider it cannabis. You're breeding with those, and there's stuff going on. So the organisms are diploids, which means there's two copies of each chromosome from each parent. You get one from each parent. So the di means two. So there's two copies. Or one pair received from each parent. So there's two pairs. The gametes they produce are haploid, meaning that they contain only one of each chromosome pair. During sexual fusion, two haploid gametes fuse to form a diploid zygote, which then grows and develops into an adult organism. Most multicelled animals and many plants have this life cycle. So this itself is not the equation, but this is what we're going to be breaking down, because it's basically the building blocks of that equation. And we're not going to do no actual math or nothing, because there is math to it, but it's just, this is just basically an introduction to this to tell you that, you know, there is like actual mathematical equations and scientific research about this stuff, and it's important to know about. And I'm not gonna sit here and tell you I'm about to do all this with mine. I sit down and do everything related to this, but it's important to know because you can keep, basically this is the beginning, so you can keep going deeper and deeper and deeper and deeper, and then that's why they have specializations of literally everything you can think of. So if you're really interested, I encourage you highly to research. Don't ever just take my word for it. Please go look it up. You know what I mean? Like and you know, shout out to everybody that's done research, and shout out to the people that are referenced in this, and all the knowledge that they have given, and you know, dedicated their lives to giving. If you're curious, go look yourself. Don't just take my word for it. Go research it. There's way more there's so many different perspectives, and you could end up learning something, and then we could converse, and you and I could just be passing on knowledge to each other, like, and that's how the community grows. So that's why I encourage everybody to don't just take my word for it. Just take it with a grain of salt and go research it yourself and figure out what you need to do for your purposes. And yeah. So what's going on here with allele frequencies is that, so let's consider for the Hardy-Weinberg equilibrium, there's two different equations, and the first one we're talking about is the allele frequency. And essentially it's an organism with two alleles, one allele represented by A, the other allele represented by B. And you can see that within the equation here, the A plus B equals P plus Q equals 1. So the A plus B and the P plus Q is the same thing. They're just saying that for the equation's purposes, they're going to call the A and B the P and Q. So the P plus Q equals 1. So you have a trait from your mom and a trait from your dad, and when they combine, they follow the laws of Mendel inheritance. So the law of independent assortment states that two alleles will separate, which is also the law of segregation, and then when they come back and combine together for the final allele, the outcome will be determined by what is the dominant trait, or what it is. So for example, like we were talking about with the dominant trait of big buds, if the one dominant trait is big bud and the other dominant trait is the green bud, so it's B, capital B and capital G, the combination of that with another capital B, capital G, that outcome is only going to be the same outcome. It'll be it'll be a big bud, green bud. Or you can have vice versa. You can have the capital B, capital G cross to a lowercase p, which is representative of the purple bud, and lowercase b, which is representative of little bud. And then when you cross those together, now you're going to have different ones. So the randomness is what is the law of segregation, and the independent assortment is a part of that. And then the dominant, that's all. Oh, so basically, let's just say Mendel's 3 laws real quick. So Mendel's 3 laws of inheritance are the law of segregation, the law of independent assortment, and the law of dominance. So the law of dominance is saying that essentially dominant traits will be more prevalent than recessive, and then the law of segregation is saying that these alleles when they combine, they will be split in half. And when they come back together to combine, it's random. And when they do combine, whenever they do combine, that's when the law of independent assortment is also displayed. And that determines what then is expressed. So that's why I was talking about the capital B, lowercase b, and the all that, because those letters are what is being represented within these equations. So you have to kind of think about that as well when you're looking at the equations. So it can be kind of confusing, I guess. So that's kind of why I'm trying to explain it. But yeah, I feel like I'm talking too much. But anyway, so the second generation, then after this would be 2 A's, 2 B's, and then AB. But like we said, the P is representative of A and the Q is representative of B. So it's actually P squared, Q squared, and then since it's A and B together, it'd be 2PQ. Because once again, the other ones are squared, so it has to all be the same. But basically it's the same. When two alleles combine, they equal one allele. So that's what this is getting at. Now, once we go to the next part, you'll see why this is playing into the next the next equation, which is the genotype frequency equation, or what is typically known as the Hardy-Weinberg equation, which is P squared plus 2P times Q plus Q squared equals 1. So these all have representations and meanings. So once again, if we remember, the P equals A, the Q equals B, but P squared represents the frequency of the homozygous dominant. So that's just talking about in this equation, when you have the numbers for it, whatever the number of occurring amount of the homozygous dominant trait, that's where you would put that in P squared. You'd put that information right there in P squared. The 2 times P times Q is the frequency of the heterozygous genotype, which, remember, homozygous is the same, heterozygous is different. And then the plus Q squared is the frequency of the homozygous recessive genotype. So if you have all the numbers for these, you can do mathematical equations and all that stuff, but we're not doing none of that. We're not doing none of that. But yeah, this is just to give you an introduction to this type of stuff. So this is another reason why I was talking about all the other terms earlier, because we're going to talk about it more here. But so that's also why this was important to discuss too. First, the allele frequency, because it is what determines the Hardy-Weinberg equation. So because the P plus Q equals 1, when they combine and have the next generation, now they have the alleles of AA, BB, and AB, which, once again, we know that the A was represented by P and the Q was represented by, or the B was represented by Q. So because of that, and knowing that, we get the P squared, Q squared, and 2 times P times Q. And then that builds from here to this, with the homozygous dominant genotype being P squared, the homozygous recessive genotype being Q squared, being q squared, and then 2 times p times q was the frequency of the heterozygous genotype, or the two different ones. So if it was big B, little b, that's heterozygous. Capital B is homozygous. So that's what this is. And then from here, oh yeah, we're already at the hour mark. From here, I'll give you a little preview or sneak peek. Excuse me, I was yawning. So from here, we're going to start talking about, and by here, I mean next week, we're going to talk about codominance, incomplete dominance, bottlenecking. We're going to talk more about gametogenesis. And then we're going to talk some about mitosis and meiosis. Why it's important, why it's tied to genetics. We're going to talk about some mutations, like point mutations. And yeah, so because just like in cannabis, there's mutations in that, so that's just stuff to know about, because if you don't want mutations. For example, there's that freak show mutation that's a really popular genetic because of its mutation. So there's a time and place for it, and we'll talk about it more. And then different aspects of how that plays into the growing and breeding. So yeah, we're gonna sip this coffee real quick. So the reason this is tied to population genetics because because that this is something to determine the question that was proposed of, well, if the dominant phenotype of humans is brown eyes, why do all humans not have brown eyes? And then the resulting factor was the development of this equation, and Punnett knew Hardy, so that's how Hardy kind of was brought into it, and he developed this along with Weinberg, but separately. Excuse me, I'm so sorry, I just burped. And this basically just explains that even though, yeah, there is dominant traits, the random occurrence of these traits being passed on through the factor of random mating, and then also through the combination of Mendel's laws, you will never get rid, at least in the natural occurring world, you won't get rid of all the recessive traits, because that means that then all of that gene pool is non-existent, and that's just not possible. So even though there is dominant traits, the random occurrence of those traits being combined and then being expressed is what still has the recessive traits being prevalent and occurring still. And once again, if we think about recessive traits, even though they're recessive, they still get passed on. So even if you don't want to think about this in the aspect of actual plants or cannabis. Think about it in the aspect of, let's say, Alzheimer's disease. So, Alzheimer's disease is a disease that affects a lot of different people in the population genetics, like we're talking about. And for example, my grandpa had it. So, with Alzheimer's, that genetic mutation, or that marker for that gene, when it's passed on to the offspring, aka my mother, there's a 50-50 chance that she got that genetic marker that determines whether or not she will develop it or have it. And then when she has another offspring, aka me, she has a 50-50 chance of passing it on to me, so on and so forth. So if I have kids, I have a 50-50 chance of so there you go. So you can think about it like that too. That's another reason why this type of stuff was developed, and then it can be applied to populations. That they look at the population of the U.S. and be like, okay, well, and I don't know the exact statistics on this. I'm just actually talking about it because it's something that I was thinking about and it occurred to me. It applies to this too, so it's another perspective that you can understand it, or help to understand it. But they can take through medical data and the database they have. They can take and see how many people have had Alzheimer's, or being since they've been recording that type of stuff. They can see how many people have had it, how they treat them, what they treat them with, what's the they'd have so much science and data and just different ways they can figure out stuff. So there's a lot of different factors that interplay with that, and then they have deduced these factors through research. So they can figure out, okay, well, what's the dominant trait, or what's the dominant marker causing Alzheimer's, and they figure that stuff out. And then from there they're like, okay, why is that happening? And then do and then you just keep going from there. So there's a lot more that plays into it. So they can figure out, well, it's affecting X amount of the population, but they can clearly see it's a recessive trait because XYZ, you know what I mean? So that's why this stuff's important, and it interplays. And it's pretty cool because it doesn't just apply to one thing. It's population genetics. It's just talking about like we said, biological just means living. So population genetics has to do with just living organisms, and it's cool that if you do sorry guys, it's cool that if you do breeding, you can take let's say for Damarino or Coltagen or P&W, they're taking extensive notes, and they're replicating data. They're taking the same cultivars and extensively repeating these breeding programs, or these crosses, or taking them to F1 or F2 or whatever they do. But they're taking notes, and they can see through time and experience working with these same cultivars that there's commonalities, and then there's uncommonalities, or uncommon things that occur. So take notes. You don't have to do all the maths and everything like that, but just take notes. Make sure you one good thing Coltagen told me, and I've heard other people say too, but when you're first growing something and you have some new cultivars, always let them just go to their like natural occurring state. Don't low stress. Don't top them. Don't do this. Don't do training on them. Because you want to see when you go through to pass these traits on. If you're breeding with something, you want to see what they do. But that's the type of notes that you need, because then you can be like, oh, okay, well, this one, yeah, it grew really good, but then when it produced the buds, they were lackluster. Or, oh yeah, no, it had really good buds, but then it didn't translate to that smoke. The smoke wasn't good. So there's a lot of different factors that play into it, and you can use these concepts to your advantage. And if you know about this stuff, it can make it a little bit like I said earlier. If you got to research more stuff, now that you kind of have a basis, I'm telling y'all right now, Do not take my word for none of this, okay? I'm telling you, I'm learning with y'all. I want you to be exposed to this knowledge, but then ultimately, I want you to go out and further your knowledge. And I'd like for you people and you guys and you gals to take this knowledge and just keep pursuing more knowledge, because it, like I said, it gets deeper and deeper. But this is really intriguing stuff. It just takes a little bit of time and effort. Cultigen will tell you it takes time to breed, it takes time to find all the bad stuff, the good stuff, I mean, yeah, like just think about having to go through and, like, if you're, let's say your plant limit's 12, just think about having to go through and smoke 12 of the same cultivar and growing those out, and then taking those, growing all those out, smoking all those, taking notes about all those, breeding with all those, and taking notes about all the offspring of those with the first generation, and then doing it again and again and again. Like, that takes a lot of time, and it takes a lot of notes, and it takes a lot of, quite honestly, it takes a lot of energy. So you have to really want to do it. And I would say a good way to start to want to get motivated to do it is to understand why you're doing it and have a purpose, and a plan written out. Just like Cultigen told me, have a purpose and have a plan of why you're doing what you're doing. Don't get me wrong, that's the whole reason any of this is even happening on this channel, and just this is because of the happy accident of having seeds being pollinated in my second grow, and having those crosses that occurred, and then having the interest of growing those ones that accidentally pollinated, growing the seeds that came from that, and the next grow, and then figuring out I had males of the Chill Out OGs by Mr. Grow at the F3s, and then being like, well, damn, they're males because they're regulars. And I was like, man, I'm going to take this and I'm going to cross it to this one that just grew in the happy accident. Bing, bong, boom. Here we are. And it's now motherfucking March 9th, and we're doing the Beginners Breeders Project, DtF and Co.'s Ohio Grow Show, and trying to learn and figure stuff out. It occurred from an accident, but just because something, like, a lot of people would consider a seeded harvest when it wasn't intended. A lot of 90% of people would consider that a failure. They would consider that, damn, like, what the fuck? And, like, don't get me wrong, I was feeling like that for a minute, but then I just thought about it, like, well, damn, like, you know, I could keep these, and I could grow these, and then that's what I did, and then it just kept building from there. So then again, or there again is the theme of building. So don't be afraid to fail. Don't be afraid to have stuff happen that you didn't want to happen. Just take it as a learning lesson. Take it at face value. Move forward, and let's keep on popping, rocking, pop, lock, and dropping. But yeah, we're gonna smack this dab one more time, guys, and I think we're about to get out of here because we're hitting up. It's about to be 8:50 here. 8:45, 8:50, whatever, and I need to go eat some food. So, that's what the fuck I'm gonna do. So yeah, let's smack one more together, you guys, and then we'll call it a night. I appreciate y'all being here. So let's smack this one once again. Shout out in the chat to everybody that's there. Don't be afraid if you got a blue moderator thing. Don't be afraid to follow each other. I encourage everybody to follow each other. Go check out what everybody else has going on. Everybody in the community that I've dealt with has been great people. So continue to spread that energy. Continue to spread those vibes. If you put out those good vibes, you get those good vibes back in return. Nobody's perfect, but it's the thought that does count, and it is the constant process of wanting to move forward and build and to be better that is the goal. That is actually what we're trying to achieve. Is the process that we want to enjoy. Therefore, that while we're doing the process of plant breeding or growing, we can then, even though it was hard work and we had to do all this other shit, it was hard, but it was thoroughly enjoyable, because through that process, we have developed something that we thoroughly enjoy. So do what works for you. Don't be afraid to learn. Don't be afraid to fail. And I say fail right now because I'm looking at this fucking sad ass plant. I have this cluster fulls by Exotic Genetics growing right now. It's up here in the veg room in my grow office. And I tried to tape it up because I broke the branch when I was doing some defoliate. And I was like, oh fuck, it's the apical stem. It's the main stem. And I tried to tape her up. I was like, oh, she's gonna be okay. It'll be all right. And matter of fact, this bitch she is not all right. I think it's done for. I might have to cut it after the live stream here. She's fucking. It's literally if you were here right now, you looked over, you'd be like, damn, dude, why is that bitch sagging like that? I'd be like, yeah. I tried to patch it up. It didn't work. I would have been a terrible medic, apparently. Hey, leave a comment too. What's been the craziest situation you had with a branch that broke off, but then you were able to save it? You had any that you were able to keep it on there and it fucking ended up being a crazy motherfucker? Because I know that, like, well, obviously if you can save them, it's just like with the high stress training or when you're like cracking the branches purposefully to make those knots in them to strengthen the stems to support the main branches and stuff. That creates those knots in there. So like if you do break a branch like that and you can get it patched up, that just makes the plant even stronger because it's like, oh, you broke, motherfucker, I'm not gonna break again. And then the plant produces all that fiber right there and makes that knuckle that you see whenever you have a spot like that. And that's what I was hoping it was gonna do. It's not. It's sad, but yeah, I'm gonna chop the bitch as soon as I get done here. It's depressing looking at it. Alright, cheers, motherfuckers. Let's hit this shit. I hope everybody is smoking that fucking fire. About to smoke this shit and get higher. Hey. Alright, here we go. Cheers, y'all. Woo. See, this is what I'm saying, dude. This thing is still burning. And you can double tap it. And it burns for 10 more seconds, dude. I'm fucking dying. Not really, but you know what I mean. Like, this shit's like, I can get you, man. Alright, you guys. Appreciate you being here. Hardy Weinberg. Punnett. Mendel. Everybody. Coltagen, P&W, Dab Marino. Everybody in the chat, what's good? One love. Peace. I hope everybody has a great night. Have a good week. Like I said, next week we'll be talking about some more terms about like stuff that's it applies, but it's not as frequently occurring. So yeah, we're gonna get that taken care of. We're gonna keep going here, and yeah, I mean, I'm feeling pretty good. I don't know about you guys, but I'm feeling pretty damn good. So let's go ahead and end this on a high note. Many blessings to you and yours, guys. I'm out of here. Oh shit.